Hello and welcome in to lesson 2, video 1, the content video for Precalculus 2. In the first video, in the lesson 1 video, the content video, I told you guys it was the most important video we were going to be going over during the semester, which was true. Now I'm going to tell you the second most important video of the semester is this one. Now I promise I'm not going to keep doing this all semester long just to drag you in, but it truly is the second most. Unit circle, absolutely the most important thing. But the different ratios and properties we're going to learn in this video, extremely important for the rest of the semester. So let me share my document camera with you. All right, so is it popping up? There we go. Okay. So Math 127 at UNLV, which is what we call Precalculus 2, is really a lot of trigonometry. And that's where we get our first introduction to it is today. So we have our definition of trig functions. Now, trig is short for trigonometry. I'm not going to write trigonometry all semester long. If I write trig, that means trigonometry. So definition of our trig functions. So we say let t be any real number and let p of xy, so that's our point with our xy coordinates, be the terminal point. On the unit circle. Determined by t. Determined So again, let t be any real number and let p of xy, that point, be the terminal point on the unit circle determined by t. From that, we have the following. Sine of t, so sine of that terminal point. So let's say, for example, pi over 6, the very first value on our unit circle, going back to video 1 here. So sine of t is just the y value. So if I want to know what is sine of pi over 6, well, it's the y value, 1/2. If I want to know what's cosine of t, that is the x value. So if I said to you, what is cosine of pi over 6? Well, it's the x value for pi over 6, which is √3/2. And then we have tangent. So yeah, these are all short. So SIN is short for sine, COS short for cosine, TAN short for tangent. So tangent of t is y over x. And of course, x can't be 0 or be undefined. And then we have what's called cosecant of t. And sine and cosecant will go hand in hand the rest of the semester. So if I'm talking about sine, the same thing applies to cosecant. If I'm talking about cosecant, I can figure out sine from that. Oh, sorry. So cosecant is 1 over y. And again, of course, y can't be 0. Secant of t, so secant and cosine go together. This is 1 over x. So again, x can't be 0. And what's called cotangent of t is x over y. So again, y can't be 0, of course. And tangent and cotangent go together. So one way to, I guess, remember this or what goes with what is that it's always S and C, S and C. So if I have sine, then the C value is cosecant. If I have cosine, that's a C, so I need the S value, secant, or vice versa. That way it just prevents you from thinking like, oh, cosine is cosecant, sine is secant. No, don't let that trick you. Hey, bud, my dog has decided to pay us a visit. All right, so these functions, and that's what they are functions. So they apply like a square root. They apply like absolute value. So anything you can or can't do with those kind of functions, the same thing applies here. If you remember, back to Precalculus 1, we talked about even and odd functions. So in this case, I'm going to say even or odd properties of these trig functions. So the even functions, so even means what? Even means that if I plug in negative x into the function, it just gives me the positive value back. So the even functions are cosine, and what goes along with cosine? Secant. And that's it. So really, if you just remember that cosine is an even function, it's the, if you think of it as quote unquote the only function, even function, well, you know that secant goes along with it, so that one applies, but everything else then would be what? It'd be odd. So all the rest, sine and cosecant, tangent and cotangent. So what this means is if I have, let's say, cosine of negative pi over 6, this is the same thing as if I just get rid of the parenthesis. Grayson, hey. That's how the even ones apply. I just get rid of the negative sign on the inside. Versus the odd functions, so if I have, let's say, sine of negative pi over 6, what happens in this case, and so here, I just remove the negative sign. Here, on the odd function, I move the negative sign to the front. So in this case, this would be the same as negative sine of positive pi over 6. And you can go look at the unit circle and see all those. Cosine of negative pi over 6 is positive root 3 over 2. Cosine of pi over 6 is also positive root 3 over 2. But in this case, sine of negative pi over 6 is negative 1/2. And then sine of pi over 6 is 1/2. So if I put a negative in front, it's what? Negative 1/2. That'd work for all of those values. We have the reciprocal identities. So reciprocal means what? It means we're just flipping a fraction. And so cosecant of t, well, if we look back here at the very start, cosecant of t is 1 over y. Well, what's y equal to? Sine of t. Therefore, cosecant is just 1 over sine of t. Similarly, secant of t. Well, secant was 1 over x. What's x? Well, that's cosine of t. And then 3, cotangent of t is 1 over tangent of t. 4, and yes, I switched pens. It's now red because this one is the reciprocal identity you're probably going to use the most this semester. tangent of t, all right, let's go back to the start again. Tangent of t is what? It's y over x. What's y? That's sine. What's x? That's cosine. So therefore, tangent is sine of t divided by cosine of t. And then again, because cotangent is just the reciprocal of tangent, I can flip these. So cotangent of t is cosine of t over sine of t, if we wanted to do that. All right. So those are some of our properties, some of our identities. Now the big one. We have what's called the Pythagorean identities. So remember back, what was our basic equation for the unit circle? It was x squared plus y squared is 1. And yes, I've switched to red pen again. That's how important this is. I'm probably even going to highlight it in a second. So, and I don't know why they change up the order here, but they do. So y is what? Y is sine. So sine squared. And so we have this notation. So sine of t squared, we just write it as sine squared of t. So when we see this notation, this means take the value of sine and square it. And so our first Pythagorean identity is sine squared of t, which is the y, plus cosine squared of t is 1. This one here, again, let me highlight it. It's not blocking it out, I hope. Yeah, good. So sine square of t plus cosine square of t is 1. I call this the holy grail of trigonometry. Also, I'm going to write here, I'm stuck. Why do I write that? It's simple. For the rest of the semester, if you are working a problem and you get to a point in that problem and you're like, man, I'm stuck. I just don't know what to do. Well, I guess I'll have to ask George in class, or maybe I can send him an email, or maybe I have to go to office hours. You can do all three of those things. That's perfectly fine. But if you find yourself getting to a point in a problem and you feel yourself say, man, I'm stuck, go back to this identity. Because I would say 9 times out of 10, or maybe 8.5 times out of 10, this identity, sine squared plus cosine squared is 1, is going to get you unstuck. The second identity. So the second identity we get by dividing all of these by cosine squared. So if I divide sine squared by cosine squared, I get what? Well, sine over cosine is tangent, so I get tangent squared. Cosine squared divided by cosine squared is 1. And 1 over cosine squared, well, 1 over cosine is secant. So if I square that, I get tangent squared plus 1 equals secant squared. And similarly, if I divide all these by sine squared, I end up with 1 plus cotangent squared t equals cosecant squared t. So these are useful. These, so that 8.5 out of 10, you'll use number 1. Maybe 1 time out of 10, you'll need one of these versions of it here, 2 or 3. But that's your holy grail, your I'm stuck, your get out of jail. Hopefully make it easier to solve those problems using the Pythagorean identity. And then one other version of this that I want to share, and it's not really a Pythagorean identity, it's a manipulation of this. So this one, the Holy Grail form, you're going to use a lot. But you might have to at times, if I subtract sine squared from both sides here, I get what? Cosine squared t is equal to 1 minus sine squared t. Or if I subtract cosine from both sides, it's gone on the left, it's over on the right. I get sine squared of t is 1 minus cosine squared t. So this one up here, call the Holy Grail. Let's call this Holy Grail 2.0. So again, you won't use it as much, but when we get to chapter 7 and we start solving trig equations, you'll have to be doing substitutions, or even in section 7.1, you'll have to be doing proofs and simplifies, and you'll be able to use these two identities here to simplify and to do and substitute. So that's why I just point that out here. On your guys' tests, at least the in-class test, you will be allowed a cheat sheet. So I would absolutely have all of this on there along with your, unit circle up to this point. Have these different identities, have the reciprocal identities, have the trig definitions if you forget. And so the last thing I just want to point out here for this lesson, you're going to have to start using your calculator to solve some of the problems that you're presented with. And so for now, so to use your calculator, make sure you are in radian mode. So if you've never changed the mode of your calculator, it's probably in degree mode, but we're not talking about degrees yet, not till maybe lesson 5, I think. Then we'll start talking about degrees. But until that point, everything we're doing is about radians. So make sure your calculator is in radian mode. All right, that wraps up video 1 for lesson 2 for Precalculus 2. Guys, come on back and we will work some sample problems for this lesson.